Yeah. So algorithm Kruskal's please. So in algorithm Kruskal's, how many parameters please? There are 4 parameters simply. E is the edge information. Next cost is the adjacency matrix, and 2 more. N number of vertices, and T will give you the information of the tree. Are we clear? So you want a tree information also. How many rows of tree? n-1 rows and 2 columns. So T is the information, and you will also maintain one more vector called as near. Not near, it is parent, right? So parent of every vertex you have to maintain. How many vertices? 1, 2, 3, 4, 5, 6 and 7. Right? So what is the first step please? The first step is very simple. Construct a min heap from the graph. Why? Because you want to extract each and every time min cost edge, right? First you have to extract 10, then you have to extract 12. How will you get it? So you construct a heap tree. So what do you mean by min heap tree? The parent node value will be less than the child. Whereas max heap tree, parent node value will be greater than the child. So what is the first step please? Construct min heap tree of edges cost. Using what you will construct a min heap tree? There is one function called as heapify. So what do you mean by heapify? You remember, right? Heapify will construct a initial heap tree. So step 1 is completed. So what is the step 2 please? Very simple. For I is equal to 1 to n, do parent of I is equal to -1. That means what? You have a parent for every vertex initially. Who is the parent of 1 here? Itself. Who is the parent of 2? Itself. Whenever parent is of itself, then you will represent as -1, -1, -1, -1, -1, -1 and -1. We have explained in disjoint set operations. Are we clear? So we have initialized for I is equal to 1 to n, parent of I is equal to -1. Parent vector is initialized. Now you have 2 more variables you want. I is equal to 0 and min cost is equal to 0.0. So you will also maintain 2 more variables, I value and min cost value. I value and min cost. So min cost is initially 0.0 and I value is what? 0. Now how many times you have to repeat the loop? In 2 conditions. What is the first condition? What is the first condition? While I less than n-1 or heap is not empty. Until heap is not empty or else I less than n-1 you will repeat the operation. So until heap is having the nodes, you have to repeat. So what is the first step please? You can have it please. So what is the first step? Delete a min cost edge from the min heap and reheapify using adjust. Okay. So delete a min cost edge from heap tree. Which heap tree? Min heap tree. So min heap tree will give you the min cost edge and reheapify using adjust. Okay. Now you tell me from the graph which edge is having min cost edge? 1 to which edge? 1 to 6. Is that clear? So what is the 1 to 6? So you will also maintain one more variable here, J and K, and also U and V. Okay. So UV and JK. These are the temporary variables. What is U, what is V, you have to come to know now. Now delete a min cost edge. So when you delete a min cost edge, you have to find J is equal to find of U and K is equal to find of V. Now you tell me what is U comma V here? What is the min cost edge? 1 comma 6. So U and V are 1 comma 6. But if you add 1 comma 6 edge in that solution, is it resulting a cycle or not? You have to check or not. right? So what you have to do is first to find out, you got one edge 1 to 6. Now find out the parent of 1 using a find method and store it in J. Find out the parent of V and store it in K. So what is the logic for find method? Do you remember? Algorithm find. Let's take a temporary variable I. So what is the algorithm for find method? Anyone? Very simple. While P of I greater than 0, if the condition is true, while P of I greater than 0, the condition is true, I is equal to P of I and return I. Now you substitute please. 1. While P of 1, what is P of 1? Minus 1. Minus 1 greater than 0. False. Immediately will come out. Return I. What is I? 1. So J value will be filled with 1. Similarly, K value also filled with 1. Whenever there is a minus 1 value for that parent, for that vertex, automatically the same vertex will get it back. You want, you can substitute also. So parent of 6 is what? Can you check it? Yeah. 6. P of 6 is what? Minus 1. Minus 1 greater than 0. False. You come out. Return I. What is I value? 6. So 6 will be stored here. So J value is what? 1. K value is what? 6. Now what you need to check? If J not equal to K. If J not equal to K means what? Addition of this edge will not form a cycle. Is that clear? So you have added 1 to 6. 1 to 6 and this edge will not form a cycle. Now you have to update that edge in the minimal spanning tree with 4 steps. So what are the 4 steps? Very simple. If J not equal to K, I is equal to I plus 1. That means what? You are adding which edge now? You are adding so you are adding, initially I was 0, I is equal to I plus 1, I value will become what? 1. Okay, so then what will you do? You have to update the tree. So updating the tree means what? T of I comma 1 is equal to and T of I comma 2 is equal to what? Now you tell me T of I comma 1 is equal to what? U. T comma I comma 2 is equal to what? V. So U and V. So what is U here? 1. What is V here? 6. So one edge is added. Okay, and also min cost should be updated. Min cost is equal to min cost plus cost of U comma V. What is the cost of U comma V? 10. So 0 plus 10, 10. Is that clear? And one more final step. What was that? You have to update the parent information. So what will you do? Union J comma K. Now you please, can you remember what is the union code please? Algorithm union of J comma K. What will you do? P of J is equal to K. Now you please see here, P of 1 is equal to K. So what will you update? P of 1 will be 6. Is that clear? So one step is completed. We will repeat 5 more steps in 5 minutes. Is that clear everybody? We will do it. If any mistakes also we will trace out also. Okay? Yeah. So if condition is completed, so while condition is, yeah. Now control comes to here. What is I value? What is I value? 1. 1 less than 6. Condition is true and heap is not empty. Fantastic. So heap is not empty. So this edge is not available now. Right? Now what will you do? J is equal to, yeah. So delete the min cost edge. After 1 to 10, who is the next min cost edge? Please find out in the given graph. 12. So 3 comma 4. Now UV will be what? 3 and 4. So U will be 3 comma 4 be the min cost edge from the heap and reheapify using adjust. So 12 also will be removed. Done. Next what will you do? Now you have to find out the parent of 3, find out the parent of 4. Find the parent of 3. Yeah. 3. P of 5. P of 3 minus 1. Minus 1 greater than 0. False. Return 3. So J value will be what? 3. K value will be what? 3 only. So I will write here only. J value will be what? 3. K value will be what? 4. J not equal to K. J not equal to K. Condition is true. 3 not equal to 4. That means what? Addition of this edge will not form a cycle. So 1 to 6 we already have. Now 3 to 4 you will add one more edge. 3 to 4 we will add the edge. Is that clear? So adding this edge will have 4 steps. What are the 4 steps? I is equal to I plus 1. You are adding the second edge. T of I comma 1 is equal to U. What is U here? 3. T of I comma 2 is equal to V. What is V here? 4. Min cost is equal to min cost plus cost of U comma V. What is the min cost? 10 plus 12. 22. And union of J comma K. What is union of 3 comma 4? Parent of 3 is equal to 4. Is that clear? So we have completed the second step. And the third step, delete a min cost edge from the given graph. What is the next min cost edge, please? 2 to 7. 2 comma 7. So now U will be what? 2. V will be what? 7. Now find out the parent of 2. Whenever it is minus 1, same value. 2. Find out the parent of 7. 7. Fantastic. J not equal to K. 2 not equal to 7. Condition is true. Immediately I is equal to I plus 1. I value will become what? 3. T of 3 comma 1. T of 3 comma 1 is equal to 2. T of 3 comma 2 is equal to 7. And min cost is equal to min cost plus cost of U comma V. So which edge you have added? 1 to 6 is already there. 3 to 4 is already there. Next 2 to 7 was added. Is that clear? 2 to 7 was added. So what? Have you updated 2 to 7? 10 plus 12, 22. 22 plus 14, 36. Yes, everybody, please. Right. So we have updated the tree information. We have updated the min cost information and union of J comma K. P of 2 is equal to 7. So parent of 2 will be updated. Now listen this carefully. How many steps you have completed? 3 steps. Now control goes to here. Delete a min cost edge. What is the next min cost edge, please? The next min cost edge is 2 to 3. Now listen this carefully. So what is U value? 2. What is V value? 3. Now find out the parent of 2. Find the parent of 2. Listen this carefully. So what is I value? 2. P of 2, 7. 7 greater than 0. Condition is true. Get inside first time. Now I value will become what? 7. P of 7 greater than 0. P of 7 is what? Minus 1. Minus 1 greater than 0. False. Return. What will you get it? J value is 7.
Yes.
Yeah. So next V value is what? 3. Find out the parent of 3. Parent of 3 is what? Now you please check it. Find out the parent of 3. P of 3. 4. 4 greater than 0. Condition is true. Get inside. And I value will become 4. P of 4 greater than 0. Minus 1. False. Return I. So K value will be what? 4. Till now we got same values actually. But now you got different values. But 7 not equal to 4. Condition is true. That means what? You can add this edge. If you add this edge, it is not forming a cycle. Don't worry. In the next step you will get a cycle. Then you will understand. So already you have added the first edge. You have added the second edge 3 to 4. You have added the third edge 2 to 7. What was the fourth edge you are adding? 2 to 3. The 2 to 3 edge is added. Is that clear? What is the 2 to 3 edge cost? 16. So we have added how many edges? 4 edges. So please update. I is equal to I plus 1. I value will be 4. T of I comma 1 is equal to U. 2. T of I comma 2 is equal to V. 3. Min cost is equal to cost of U comma V. 36 plus 16. 52. Now please listen this carefully. Union of J comma K. So what you have to do? P of 2 is equal to 3. So P of 2 will become, union of J comma K. Please listen this carefully. So what is J value? 7. What is K value? 4. Parent of 7 is equal to 4. So here you have to update. Is that clear? Now listen this carefully. 2 times you will get a cycle. Now control goes here. Delete a min cost edge. What is the next min cost edge? Please observe.
4 to 7.
18. 7 to 4. 4 to 7. Okay. So now please tell me what is U value? 4. What is V value? 7. Now listen this carefully everybody. Now find out the parent of, find the parent of U. Now please come here. So what is the 4 parent? Please check it. P of 4 minus 1. So you will get the same. Very good. Now find the parent of 7.
4.
Now please see here. P of 7. What is P of 7? 4. 4 greater than 0. Condition is true. Get inside. I value will become what? 4. Now P of 4 is what? Minus 1. False. You will come out. What is written? I? 4 only. So J value is 4 and K value is also 4. That means what? If you add this 7 comma 4, you will get a cycle. So this was the previous edges you have added already. But which edge you are trying to add now? 4 to 7. If you add this edge, will it form a cycle or not?
Yes.
So do not add. So J not equal to K. Condition is false. Don't add, don't consider this edge. Control goes to the, once again, one more step. So that means what? This 7 to 4 edge will not be considered. What is the next min cost edge, please? 4 to 5. Now once again, 4 to 5. Now please tell me, find out the parent of 4. 4. Find out the parent of 5. 5. Why? Because both are minus 1. 4 not equal to 5, condition is true. I is equal to I plus 1, you are adding the fifth edge. T of I comma 1 is equal to 4. T of I comma 2 is equal to 5. Min cost is equal to cost of 52 plus, what is the next min cost? 22. So you have not added this edge, you have added this edge. Is that clear? 4 to 5 you have added. So what is the 4 to 5 cost edge? 22. Okay, so that was 10, 14, 16 and 12. Now listen this carefully. Have you updated all the values? Min cost is equal to min cost is updated 52 plus 22. 74. And union of J comma K. Parent of 4 is equal to 5. Parent of this parent information is for which graph? This span. Is that clear? You can observe. Now control comes here. Delete a min cost edge. So what is the next min cost edge? Please check it, everybody. 24. Now listen this carefully. If you add 5 to 7, will it form a cycle? Yes. Now let's check whether the code is detecting or not. Actually, if you add this edge, you will get a cycle. But we should not add that edge. Now what will happen? Let's check it. So delete a min cost edge. What is the least min cost edge? 5 to 7. Find the parent of 5. 5 only. Find the parent of 7. Now you please check it. Find the parent of 8 తీసుకుంటామండి 5 to 7 కదా 5 to 7 అయినా yeah 5 to 7 parent of 5 is what 5 parent of 7 now please check it parent of 7 is what 4 greater than 0 condition is true so value will become 4 now listen this carefully parent P of 4 is what 5 greater than 0 true I will become 5 now listen this carefully P of 5 is what minus 1 greater than 0 false what is written I 5 so J value is 5 and K value is 5 J not equal to K then condition is will become false so this edge will not be considered is that clear so already 1 to 6 you have 2 to 3 you have 3 to 4 you have 2 to 7 you have and 5 to 4 you already have but if you add this edge we'll get a cycle that's why don't consider this edge so this edge will not be considered what is the next min cost edge please yeah we have only left out with 25 and 28 so what is the next min cost edge 25 5 and 6 who is the parent of 5 5 itself who is the parent of 6 6 itself 5 not equal to 6 condition is true I is equal to I plus 1 I value will become 6 this is the last step please so in step 6 what will you do I is equal to I plus 1 6 T of I comma 1 5 T of I comma 2 6 3 information of min cost is equal to cost of 74 plus 25 99 is that clear and union of J comma K parent of 5 is equal to 6 that means what you have added the last edge so what is the least cost 10 14 16 12 22 and 25 what is the cost please add it total is 99 now please check the condition I value will be what 6 less than 6 condition will become false you come out now you can come out of the loop in two ways what is the first way you got the spanning tree. What is another way? You are unable to got the spanning tree where the graph completed. Sometimes you may not get the spanning tree. So how to check that condition, please? Anyone? Very simple. After coming out of the loop, you have to check if I not equal to n minus 1 means what? There is no spanning tree for the given graph. If I not equal to n minus 1. But actually what is I value? 6. What is n minus 1? 6. The condition will become false here. That means what? Else return min cost. What is the min cost? 90. That means what? You can rewrite the condition also. I equal to n minus 1, return min cost. Otherwise, there is no spanning tree for the given graph. So this is about Kruskal's algorithm, where what are we doing? Each and every time taking the min cost edge and adding to the spanning tree, but before adding to the spanning tree, checking whether it is giving the cycle or not, using a find and union methods. Is that clear? So that is about Kruskal's algorithm. In the next algorithm, we will start about prims.